All right, welcome back, everybody. So as I was explaining to my in-person class here, all we're going to do today is just kind of go over section 5.7 and talk through the homework. I'll answer any questions that we need to. I want to do a couple more problems from section 5.7. Just a couple more of the algebraic ones, because in my opinion, those ones are a little bit more difficult than just the graphing ones. I want to show you what it looks like on the graphing calculator a little bit, so you can kind of reason it through that way as well. Kind of tell what's happening within the algebra by looking at the graph. But then after that, I just want to give you guys your homework to work on. The homework for tonight is a worksheet, section 5.7 worksheet. Okay. We're going to change the computer yet. So it's going to be kind of an easier day today. So let's start by checking the homework. Here is the first part here. Here's 13. The zeros for that one, I'd be fine if you left them as plus or minus radical six. Somebody asked me yesterday, so is there a rule? When do we need to find the zeros? When don't we need to find the zeros? I will say this. If it crosses the x-axis, find the zeros. Okay, if it crosses the x-axis, find the zeros somehow. If you know it's not going to cross the x-axis, you don't need to worry about finding the zeros. Pretty much the rule there. So remember, all the same rules still apply. You find whether it opens upward or downward. You do negative b over 2a. You plug it in to find the axis of symmetry. You find the vertex, or sorry, you plug it in to find the vertex, and then you find the y-intercept. In this case, you kind of have to find the zeros because the vertex is the y-intercept. Positive 3 is the vertex. If I take negative b over 2a, b is 0, that whole fraction is going to turn to 0. So in this case, my axis of symmetry is the y-axis. So unfortunately, we only have 0, 3. We know that it points downward, so we know it's going to go generally downward. But then, we don't have any other points to show how wide or narrow it really is. So the best route to take would just be to find the zeros. The nice thing here is that since it has no b term, you can solve directly for x. Subtract the 3 over to the other side, divide by negative 1/2. You're going to get 6 is equal to x squared. So you could say plus or minus radical 6, but that's kind of hard to graph. I'm not really sure where radical 6 is. So just use the decimal form, and it's 2.45. Positive or negative, 2.45. So you come over here, about 2.5, here, about 2.5, dotted line, and then you say, okay, since it's greater than, well, let's pick a test point. If I ran 0, 0 through this, I would get 0 is greater than 3, which is not a true statement. So therefore, that's why I'm changing the outside. Let me scroll down. There's 15. Same thing there. But this one's even weirder because it's not going to cross the x-axis. Right? So I go, my b value is 0, so my whole axis of symmetry turns to 0, which means that my y-axis is my axis of symmetry. I plug it in and I get 6, which is my y-intercept. So we're sitting there, we're like, oh, okay, I've only got 1 point. I know that it goes upward. But I've only got 1 point. How the heck am I going to finish graphing this? Well, good old standby, make a table. Make an XY table. Plug in 1, you get 7. Plug in 2, you get 10. Right? You don't need to plug in 2 points. I just did that for repetition's sake. There you go. It's on the right side there, so flip it over for the left side here and here. It is a solid line because it's an r equal to. And then we say, okay, let's pick a test point. It's gonna annoy me. Hold on one second. I pick a test point. Let's pick 0, 0. Okay. Let's pick 0, 0. Let's run 0, 0 through. That would be 0 is greater than 6 in the end, because 0 squared is 0 plus 6 is 6. So 0 greater than 6? No. So shade on the opposite side of 0, 0, which in this case is the inside of the parabola. 13 and 15 were kind of weird ones to graph, in my opinion. They're not really normal ones because they have no b term. The axis of symmetry is the y-axis. 17 is more like it. 17 is much more doable. And that one's kind of an easier one because do I even need to attempt to find the zeros? No. I see that my vertex, my axis symmetry is 1. My vertex, therefore, is 1, 5. Okay, well, if that's the case, and my y-intercept is 6, then I know, and it's going to point up, then I know that it's not going to cross the x-axis. So I didn't need to find. My zeros would have eyes in them. So therefore, I don't even need to attempt to find it. I make my solid line shade on the outside. I pick 0, 0. I'm going to get 0 is less than or equal to 6, which is a true statement this time. So I shade on the side of 0, 0. Take a look here. Did it really jump there? Yeah, 13. Okay, 27, 35 to 39. Here's 27. Okay, so this one was the football. Football thrown by a quarterback follows a path given by that function, negative 0.0090095 x squared plus x plus 7, where h is the height of the ball in feet and x is the horizontal distance traveled in feet. If any height less than 10 feet can be caught or knocked down, at what distances away from the quarterback can the ball be knocked down? So just kind of visualizing what's happening here. Here's my quarterback. There's Big Ben. This is Big Ben. There's Baker Mayfield. Ooh. If it was Big Ben, he'd be wearing black. So, yeah. There we go. Okay, so he throws the ball. Don't confuse the dotted line with any sort of inequality there yet. He throws the ball. The ball's coming out of the top of his head. And they say, okay, any feet less than 10 feet, any lower than this line, the ball could possibly get knocked down. So it could jump up, knock it down. Okay? So I'm asking, what distances away from the quarterback? So like right here and down, or over here and that way. What distances away from the quarterback does the defender need to be able to knock down the pass? So basically, I want to know when the height is going to be less than 10, right? When is the height going to be less than 10? Find the x values for when the height is going to be less than 10. All right, so that's my inequality that I create. I don't know about you guys, but I'm not completing the square. I'm not trying to factor that. So let's just use the quadratic formula. Plug it in, and you see the two values there, 3.09 and 102.17. Now, you could logically reason it through, saying it's only on this side or that side. So we could say less than 3.09 or greater than 102.17. But it's good to run that whole sign analysis thing where you pick test points. These are my 3 test points that we see. I picked 0, 10, and 110. And I get a yes, a no, and a yes. Somebody asked me, so with period, is it always going to turn out to be a yes, no, yes? Or a no, yes, no? And I said, for our purposes in this chapter right now, it's always going to turn out to be a yes, no, yes, or a no, yes, no. If it doesn't, you goofed somehow. You got the wrong zeros. Something went awry earlier. Okay. Now, later on in the year, we will do this process. We will do this whole sign analysis thing again, and that may change. Sometimes when we do this with different functions, it could be like a no, yes, yes, or a yes, yes, no. Okay. It just kind of depends on what the function looks like. So because this is always going to be like a quadratic and a linear, if for our purposes right now, it's always going to be either a yes, no, yes, or a no, yes, no. For in this case, it's a yes, no, yes, so I could kind of draw it in right here. Here, over, right? For any distance less than, and maybe open dots there, sorry, less than 3.09 or greater than 102.17. And again, what are we doing here? We're analyzing, are there solutions in that area? Because if one point is a solution in that area, all points are solutions in that area. If one point somewhere between 3.09 and 102.17 is a solution, all points between there are solutions, but there aren't any, so none of them are. Okay, so let's take a look at that again. Here's 35 and 37. Again, the difficulty will come now with how difficult the quadratics are to solve. Hopefully this whole number line thing, sign analysis thing, is getting a little bit better. Hopefully we're catching on to that. But the difficulty now comes with how difficult the quadratic is to solve. Like, look at 35. Man, that's an easy one. Factors in negative 24, then I have to get to negative 5, negative 8, negative 3. Or sorry, negative 8 plus 3. So my zeros are positive 8, negative 3. Okay, so that means I can pick 3 test points somewhere. So here are my 2 values. My test points somewhere here, here, and here. Okay, let's choose, we chose negative 5, 0, and 10. You should have gotten a no, yes, no. You can choose different values. Did you have to pick negative 5? No. Did you have to pick 0? No. Did you have to pick 10? No. But the interpretation after that, what you decide past that should all be the same as what I have on the board. Okay, you should be saying a no, yes, no, which therefore is an and inequality, something that will say, okay, that means I only have solutions in there. Please do not say x is greater than or equal to negative 3 and x is less than or equal to 8. Like, write the word and. No, remember, that's a compound inequality. You write it as one statement. 37 up there. See, now this one's a little bit more difficult because it's not factorable. Right? It's not factorable. So I got to use quadratic formula. I got to use completing the square somehow. But this is what I end with. Remember, people, if I want to write this as a number line, I've got to figure out where it is. So I've got to get it down to its decimal value. The square root of 17 is like 4.1 something, right? So it's 1 plus, 1 minus those decimal values. And I get negative 1.28 and 0.78. And these are the critical, so those are the critical points. These are the tested values that we used here. X equals negative 2, x equals 0, and x equals 1. Turns out that this is a no, yes, no. It's a no, yes, no. And remember, all I'm doing with those tested values is running those x values back through my original problem to see if it would be a solution in there. Okay, so it's a no, yes, no. Obviously, it's pointing in toward one another. So that's an and inequality. And then here's 39. Again, 39, not factorable. Got to do quadratic formula or completing the square. You know, obviously, I'm not going to do completing the square here. I have to take 11 over to either side and then divide it by 3. And then I've got some messy fractions going on. Okay. So I'll just run the quadratic formula. Negative 6 plus or minus radical 24 over 6. I could reduce down radical 24, but why? I'm going to have to make it a decimal anyway. So negative 0.18 and negative 1.82 are my 2 critical points. And then I take my tested values. I use negative 2, negative 1, and 0. And it turns out to be another, I feel like all of them were no, yes, no's on the homework. Okay, questions on any of those? Questions on any of the homework problems? We feel okay? Okay, let's get out some scrap paper, and we're just going to do a couple more problems. We're not going to do any new notes today, not learning anything new today. We're just going to do a couple more problems of this whole solving by algebra. Okay? Excuse me. Oh, your tests. I do have them graded. I finished grading them last night, but it was like 11:30, and I was like, I don't want to put these grading right now. So I didn't put them in the gradebook. As soon as we get done here and I start working, I'll throw them in the gradebook. So go ahead, write this one down. X squared plus 6x plus 3 is less than negative 2. Ignore the number 6. Fill this up a worksheet somewhere. I didn't steal this worksheet, did I? Oh, wait. Gee. Do we actually do it? Oh, cool. I'll write that down. 1, 2, 4, 2, 8, and 9. 1, 2, problem on the worksheet. Why not just say don't do 3? Okay, well maybe we'll do 3 then on here. Well, I want to do one that you don't have to do. What's 8? Let's do 3. Sorry, I lied, folks. You'll have to do that problem in a minute. I'm so sorry. I am so sorry. Please forgive me. Wait a second. I'm just thinking. Hold on a minute. Hold on. 0. Oh, I'm okay. We're on. All right, let's do this one. X squared plus 3x minus 14 is less than or equal to 14. Yeah. This is the one you don't have to do on that. Okay. So let's go through the process again. First thing that you want to do is treat it like an equality, right? Treat it like an equality, because I want to figure out the critical points. How do you figure out those critical points? Is that you solve the equation, right? Wherever the equation comes in, where the solution to the equation is, that's where the critical points are. All right, so we subtract the 14 over to the other side, because we got to get it set equal to 0. So that means I've got an x squared plus 3x minus 28 is equal to 0. No, I would subtract it because it's already positive over to the other side.
Oh.
Yeah. Oh, if you're thinking of putting it over to the other side, you can do that too. I mean, in that respect, you could just go ahead and start completing the square if you wanted to. But does this factor? Factors of 28. 4 and 7, right? 4 and 7 have a difference of 3, right? So sweet. This one factors? Awesome. So factors of negative 28 that will add to get to positive 3 are negative 4 times 7. Negative 4 times 7. So that means that this will factor into x minus 4, x plus 7. So that means I've got an x equals 4 or an x equals negative 7. Could I have done the quadratic formula? Of course. Could I have completed the square? Of course. But it factors, so that's easy. If you didn't see that it factored, by all means, use the quadratic formula. Complete the square, sure. Okay, so let's go to our, let me erase away this, give myself a little bit more room. Let's go to our number line now. Okay. And let's plot negative 7 and positive 4. And let's pick 3 testing values. Pick 3 testing values. One here, and one here. Okay, something to the left of negative 7. What do you guys want to choose? Ooh, negative 10. Okay, let's go. Negative 10. What do you want to do between negative 7 and positive 4? 0. Thank you for choosing 0. What do you want to do above 4? 7. Okay. In essence, 5 is the same as 7 in this respect, right? I don't care whether it's 5 or 7 because they're both going to lead me to the same conclusion. Okay, so what do? We go back into our original with those 3 testing values. So we say 10 squared plus 3 times 10 minus 14. And I get 116. I get 116 less than or equal to 14. Is that a true statement? No. So I can already tell, as long as I've kind of done my problem correctly, as long as I've found the correct zeros, this should probably be a no, yes, no. You know, this is kind of a good check for yourself. If this comes out to be like a no, no, yes, you did something wrong. You found the zeros incorrectly, or you plugged it in wrong. So if I plug in 0, I'm going to get just my y-intercept here, right? Negative 14 is less than or equal to 14. Is that a true statement? Yes. The exclamation points are a must. Just gotta emphatically say it. Yes. And then 7, so I've got 7 squared plus 3 times 7 minus 14 is 56. 56 less than or equal to 14? No. Okay, so that means that my solutions lie on the left side of -7 and on the right side of 4. Now, again, give me the algebraic statement that says this. So this says that x is less than or equal to -7. Use the word or. X is greater than or equal to 4, because ors point out. So there's my answer. Questions about that? No, because, what am I thinking? Holy man. Before 8:15, I can still make mistakes. Whoa, yikes. I got in the or mode. What the heck? Jeez. Wake up. I haven't had any of my coffee yet. I'll blame it on that. Oh my gosh, it did it again. Oh my gosh, it did it again. Thank you. If anybody else would like to come up and teach the class for me, I would really appreciate it. So x goes in the middle. Yikes. Yowza. Okay, there we go. That's much better. Cole will probably watch the video. He'll be like, you screwed up. You screwed up. Okay. All right. Any questions on that one? Any questions on that one? I wanted to do this. I wanted to show you what it looks like graphically as well. You don't have to do this along with me. If you'd like to, you can. But I wanted to show you what it looks like in the graph, because I think it's good to kind of point out where this ties in graphically. X squared plus 3x minus 14, and then 14. So what did I do here? I put the y1 on the left side, or on the y1 is the left side, y2 is the right side. I'm going to treat this like a system of equations. Okay, x squared plus 3x minus 14 goes on the left, so it's the y1. 14 is on the right. So take a look here. I'm going to zoom 6 this. I'm not sure if I'm going to see it. Okay, so there's my parabola. I'm not seeing my 14 line because I only have a 10 by 10 window. Remember, this is a horizontal line at 14. So let's zoom fit and see what happens. Maybe this will give us a good view. Okay, there's my parabola, and there's my 14. Okay. So again, this is what this parabola looks like. It's opening upward, y-intercept of -14. So think about what's happening here. I want to know when y1 is less than or equal to y2. I want to know when the y values of the parabola are going to be less than or equal to the y values of the horizontal line. So if visually speaking, I want to know when the parabola is underneath the horizontal line. So this is when the parabola is underneath the horizontal line, only in that location, okay? And that's when we say, okay, I want x values only between this point and this point. If I choose x values only between that point and that point, that's going to make this equation, this inequality, true. So you could go in and say, second, calculate the intersection points. First curve, enter. Second curve, enter. Guess. Let's go find the right one. I can already tell it's going to be +4. Yeah, x equals +4 over there, right? And I can do that again. Second, calculate the intersection point. First curve, enter. Second curve, enter. And now I got to guess all the way over. If I don't guess over there, then it's going to get my 4 again.
Can you not write it down?
No, if I do that on the screen, it will like try to lock a location on the screen. That's pretty close to me, right on there. -7. Yeah. So I see my 2 locations there, -7, +4, and then I found them on my calculator. -7, +4, and I want only x values in between there. Okay. So you can kind of use your graph to kind of verify what you're seeing there. Yeah. All right, questions on that? Okay, I'm done talking. I'll shut up now. Got 18 minutes to start our homework. I'll shut off the video. No problem. Ornaments due Monday. Don't forget, due Monday. I've already got some turned in. The tree's looking a little bit more decorated. Still looking a little scraggly. Good for an old tree, though. There you go. There you go. There you go. Here. 2 for the price of 1. Okay. So long, everybody watching at home. Anybody want to say bye? Bye. Okay.
Why did I wait?
I don't know. Anna Waltz waved. I'm just calling her out.